Okay, this says the function f has derivatives of all orders for all real numbers x. Assume f of 2 is 7, f prime of 2 is negative 2, etc. Write p of x, the third degree Taylor polynomial for f about x equals 2, and use it to approximate f of 2.1. Okay, so we know that so p of x should be, according to the recipe, f of 2 plus f prime of 2 times x minus 2 plus f double prime of 2 times x minus 2 squared over 2 factorial. And how many are we doing here? Is it 3? Yeah, the third degree. Okay, and so I just gotta go substitute in all these things, and those are given to me, and then I gotta plug in 2.1, and then I'll see what that gives me. So f of 2 is 7, so I'm gonna get, so p of x is 7 plus, and then f prime is 2, and then, so 2x minus 2, and then f double prime is 4. So it's 4 over 2 factorial x minus 2 squared. And then f triple prime is negative 1. Okay, now, so there's our polynomial. We got to plug in 2.1. So, and then it's just calculator. Let's just do this mentally. 2 minus 2.1 is 0.1. This is obviously 2. Okay. Now, when you do that and round it to the nearest thousandth, it should be about equal to, apparently, 6.820. Okay, rounded to the nearest thousandth. Okay, so that would be here. So now let's use the remainder estimation theorem to find an upper bound. So the remainder estimation theorem says that, so we're using the third degree Taylor polynomial to approximate the function at 2.1, and that'll be less than or equal to the maximum value of the fourth derivative. I'll just record that over here somewhere. Maybe like over here. So remember, m is the maximum value of the n plus first of the absolute value of the n plus first derivative. So in this case, that'll be the fourth derivative of our function. Sorry, my writing is being weird. One more time. Okay, on the interval, in this case 2 to wherever we're approximating. And so that's just going to be given to us, and then it's x minus, I'll just keep in the, put it in generically, and then I'll substitute the numbers in. Okay, so if our n is 3, then I put 3's in. So this becomes a 4 up here. Our x is 2.1, and the center is 2. And then our m, like our m is given to us, it's just handed to us. Okay, notice they're telling us an upper bound for the absolute value of the fourth derivative, so that's 3,000. Okay, sorry, this isn't deserve a factorial, that's an exponent. All right, so like, look, I'm going to punch this into the calculator, and that's 3,000 times 0.1 to the fourth, and then I'm dividing that by 4 factorial, and I'm getting exactly, so no need to round, I'm getting exactly 0.125, sorry, 0.0125. Okay. Okay, so the upper bound there is 0.0125. Says, so the idea here now is like, this is one way of notating the error, but it's also the true value minus our approximation in absolute value. And what we just learned is that that's less than or equal to 0.0125. And so when you have an absolute value like this, you can always turn it into a double inequality like this. And then if you add, and then so like, so P of 2.1 here we got, right? What was that? That was 6.820. Okay, so now I've got that negative 0.0125 less than or equal to f of 2.1 minus 6.820. And then if you add this to every section, what you do is you trap the value of f of 2.1 in the middle, and now we've got like a true, we've bounded it on both sides, and so we'll know, we essentially know like what the true value is. We don't, I mean, where we can approximate the true value. We know it's between these two numbers, and that can be useful. So let's see, 0.10125. So I'm getting 6 points. So here I'm getting, once I do the subtraction, 6.8075. And on the other side, I would be getting 6.8325. So what that tells me is that the true value is somewhere in between there. Okay, that we're guaranteed that the true value is in between those two numbers. So going back over here, the lower bound of f of 2.1, as I mentioned, would be 6.8075. Okay, and an upper bound is 6.8325. Therefore, f of 2.1 cannot be less than 6.8 and cannot be greater than 7. Yeah, so like this was, we're trying to show this, which this is obviously true if what we just showed is true, right? So all that work was to show that the true value of f of 2.1, it cannot possibly be 7, right? We don't know what it is exactly, but we know it can't be 7. And we know it's actually more precisely in between these two numbers. Okay, I hope that helps.